We are going to learn how to create different charts. In Python, they are called plots, using Matplotlib and pyplot. In order to use Matplotlib, you do need to install it. And you're going to have to do that in the command prompt. So you can either use Windows PowerShell or just the regular command prompt, but you are going to want to launch it, which I have done. And then you're going to want to key in this command to install Matplotlib. And you can see I keyed it in here already. And this is what it looked like when it ran. Now, once you have that installed, then you can start entering the Python code to create your different charts. And we have to import matplotlib.pyplot. And that is a mouthful to say. It is given an alias of PLT, which is a little shorter to code and easier to say. And so when we execute different pyplot commands, instead of prefixing it with matplotlib.pyplot, we prefix with PLT. And the plot function will create a line chart by default. There is a bar function and a scatter function and a histogram function, all sorts of different functions to create the different types of charts. With a line chart, which is what this one does, you give it your X and Y points, and it will create the chart. An alternate would be just letting it chart X points or just letting it chart Y points. Well, once you've given it the data, you have to use the show function, and it will basically open a little window and draw your chart. You run your code just like you normally do. So here is a little example. And you can actually run this. So I'm going to copy it. And I'm just going to open up a practice. And we'll pull this over here. So I can copy and paste that right into here, and I can run it. Now, if you have any syntax errors, they will show up down here. And let us see. Oh, I do not think it wants that capitalized. Here we go. Try that again. Oh, it opened. I can see it down here. This is kind of the weird thing. This is the figure. So if I click on this, actually opened in my other screen, here it is. Pretty plain, kind of boring, but you will learn how to customize it. So that is all there is to creating a very simple line chart. So it would look a little bit more exciting if we actually gave it a title and we labeled the X and Y axis. And you can do that with some additional functions. So we have plt.ylabel, plt.title. There's also a X label, and they will display in the various axes. After the title, the label, or the label text, there are some parameters you can enter. You can change the font size. You can actually change the font family. You can apply color. Okay, so here is a little example where I've got a different font family. I changed the font size and the color. It is pretty easy. I'm going to close this to make these little adjustments. We'll do plt.title, boring line chart. And then we'll do plt.y label, increments of 20. And then we'll go ahead and you can see that it did run. So now I've got to pull it over. And you can see increments of 20, boring line chart. I could make it a little bit more exciting by adding some color. And it is pretty simple to do. We'll do color equals hot pink, or no, deep pink, I think is the HTML color. And you'll notice I have one open, so I do need to close that before I'm going to get this one to display. And there it is. A little bit more exciting, but you guys kind of get the gist of how this works. Quite often people like the grid to display, so you can do plt.grid. And then we don't really pass that any data. We just run it. And you get the grid lines, which personally, I find it easier to follow values if there's grid lines in there. And then we get to our subplot function. Now, the textbook author likes to use this function. It is really designed for multiple charts. If you wanted to do more than one chart, you would use the subplot function. And you basically have your data that you're going to chart. You tell it how many rows of charts you want, how many columns of charts you want, and what chart number you are currently creating. Okay, so I'm telling it I have one row, I have two columns, and this is chart number 1. Then down here, I have one row, two columns, and this data is for chart number 2. And you can see it's calories burned and calories consumed. So I can simply copy and paste this. Got to get rid of my boring chart before it'll do the new one. And I can see that's capitalized. I am going to have to fix that. That should not be capitalized. Try this again. It is kind of annoying that it always opens in the other window, but here it is. And you'll notice that this is kind of a nice little interface. I mean, you can save the figure as a ping graphic. What if you want to put a title across multiple plots? You can using the super title function. So here we will add a super title. Now there's only one super title. And so this is calories, right? This one is on calories. Calories burned versus consumed. All right, so we'll run it. And there you can see the title. So you'll notice that when you have a super title, it is basically the title for the whole chart. Then we also have a title function, which becomes, in a sense, a subtitle. And if you have multiple charts, it's just a title for that single chart, not for the whole thing. So in addition to the various functions that deal with the data that is being charted and the titles, we can also control the ticks. So what are the ticks? So these are those little markers that you see above the numbers. You can adjust the color and the length and the width of those little markers. And so here is an example of how that looks, adjusting those tick parameters. You can also adjust the numbers that are being used on the X and the Y axis. And the way you do that is you use the access method. So here we have plt.access, the minimum X and the maximum X, minimum Y, and maximum Y. Okay, so then down here, you can kind of see what I've done. For my X, I set a minimum and maximum, which you can see. And then I did the same thing over here for the Y. Okay, so if you don't like the default scales on your axes, you can change them. And if you want to change the ticks, you can change those as well. And I should point out what the textbook author does with subplots is they will give it a name. And then if you do that, then for the plot itself, and it's really only the plot that's affected by this. If it's a bar chart, it's the bar chart or the scatter. Plot is for line. You prefix that with AX instead of PLT. Okay, so I would probably call this one AX2. Oops, AX2 equals. And then I have to use that here. Okay, and you can see it did pop up, of course, on the other screen. Looks the exact same as it did before. Okay, it's just another way of setting up your charts. Now, I did show you how when you run your app and you get that figure window pop up, how you can save by clicking the save icon. You can actually set up your code to automatically save. So if you do not want to go to the trouble of clicking on the save icon, there is a command that you can use to save as well. Okay, and so this would be the command that you would have to insert to save. Now we've looked at a couple different arguments with the tick parameters. We are going to be looking at some additional arguments that you can actually enter in the plot parameters. So this is where you put your X and Y series. And it doesn't matter if you're doing a scatter chart or a bar chart or a plot, which is a line chart. You can provide these arguments. And some are specific to like a line chart or any kind of chart where there's markers shown. You can actually specify the type of marker that you want. So if you look here, we have all sorts of different types of markers. And so if I wanted, let's see, an O, I know that's probably a more boring one. I can add the argument marker equals O, and that's the letter O. And then let's do a different one on this one. Marker equals, I'm going to do a diamond. Okay, we'll add a couple before we run it. Okay, so you can see all of your choices there. You can also control how the line looks. So by default, you're going to get a solid line. And we can do a dashed line, a dotted line, a dash and a dot. Got lots of options. So the parameter is ls for line style. And I think I'm going to do, in double quotes, a colon. That will give me the dotted line. And then down here, I'm going to do a dash. We can also add color. So to add color, you can just say C for color. And then you can either use hex values, you can use HTML color names. You can also use RGBs in some of the charts. So I am going to do light green. And then down here, let's see, turquoise. Hopefully I spell it right. I have to pick a difficult word. Okay. So at this point, I'm going to run it because we've got several different parameters that we've added. Hopefully I don't have a typo. So seeing that little symbol is awesome because that means it worked. So we'll pull this over here. And you can see I've got my circle markers here and I've got my dashed line. And here I've got diamonds for my markers. And I think this is a dotted line. This was supposed to be dashed, but it doesn't look very dashed. So I'm going to change it. Yeah, I'm going to, let's try a dash and a dot. And then there is another parameter for the width. So we can do LW for width and give it a value. And just so that you can kind of see for the line width, this is what a 4 looks like. So, you know, depending on the line style, you may want a bigger or smaller number. I'm going to try 2 for my width. And let's run it. And I definitely do like the width because I do think it makes, especially if you're using these different line styles, I think it makes it easier to see your line. Okay, but you kind of get a feel for what these arguments can do. So in addition to these arguments that let you customize your plots, there are also built-in styles. And I'm not a huge fan of the built-in styles, but I will show you um, how to use them. You can see which styles you have if you go into the command prompt, key Python, and then you're going to see, like the chevrons over there. And then key in the import matplotlib.pyplot as PLT. Then you can actually look at the styles available and it will show you all of the different style names. Okay, so why do we want the different style names? Because if you apply one, you have to say plt.style.use and then give it that name. And so what I did was I applied several and showed you what they look like. And I didn't necessarily like the default look, so you can see that I added some color and some line widths. So it is perfectly okay to use these styles and then adjust them with color, with line styles, with markers, any way that you see fit, you can certainly adjust them. And then if the title is too big, you can use the font size argument to change the size of the title. Now, so far, we have been looking at line charts, which use the plot function. We are going to take a look at some of the other types of charts that you can create using Matplotlib. We will take a look at scatter, bar, pie, and histogram. For more information on these other types, I did provide a link to some tutorials for you. So with scatter function, basically you are plotting against the X and Y axis, and you may be plotting multiple values on typically it's the Y axis. It just depends on the direction that you want your scatter to go. This little example is plotting test scores, the points that the different students have received. And you can see that we have a score range, and we're plotting the pretest scores and the post-test scores using this range. So I'm giving it pretest and the score range in both scatters. And then I've assigned each one a different color. And you'll notice I've added a label. Anytime you have more than one series, you are going to want to display a legend. So the easiest way to display the legend is to add the labels in the series that you're graphing. And then you can use the legend function and it will pull those labels in. So for the legend function, you basically need to give it a position. And you can adjust the font size if you want, and you can also control the number of columns if you want. With only two things that I'm plotting, obviously it's going to be 2 columns, but I could say 1, and then they would stack on top of each other. If you add a legend, you are definitely going to want to give it the location. And if you're not sure of what location to use, you can actually use best and let Matplotlib figure it out. Otherwise, you can use any of these commands to position that legend. In addition to displaying a legend, you may want to change the size of the dots in the scatter. And to do that, you have to add the S attribute right in the scatter function arguments. So S is short for size. So S equals, and then the size that you want the dot to be. So just to give you an idea, I left the post-test dots at the default size. And for the pre-test ones, I set the size to 200 so you can kind of see the difference. The scatter function is a pretty easy one to convert to 3D. So I wanted to show you how that works in 3D because the difference between 2D and 3D is for 3D, you need to have a Z value. And so we're using the same scores as before. We're importing Matplotlib just like we did before. But now we need a Z value. So you can see that I've set a pre-test week and a post-test week to 0. Now, could I have just entered zeros here, in the scatter function arguments? Yes, I could. Okay, so I just did it this way in case I wanted to change them. Then you will notice that I set AX to plt.subplot, and the reason I'm using subplot is because I need to tell it I'm using a 3D projection. Now, I set that equal to a variable AX, which is short for axis. And then I'm using AX.scatter to send the different arguments to the scatter function. That's the only thing I have to prefix with AX. Okay, so really wasn't a lot of adjustments that had to be made to this in order to get the 3D look. For bar charts, they are not quite as straightforward. Actually, if you're just going to do one bar, it is pretty straightforward. Okay, so this is one bar. You can see this is going to go on my X axis. There, that's my category X labels. And then this is the data that I am charting. So I'm giving it my category X, I'm giving it my Y series, got the color, and I'm specifying the widths of the bars. Then I've added a X and Y axis label, a title for my chart, and that's pretty much it. And here is the chart. So that's pretty straightforward. It's also straightforward to create a horizontal bar chart. The only difference is that instead of saying bar, I have to say bar H. Okay, that's the only difference. You may want to adjust the labels because I think the labels are going to be messed up. But I'm going to run it, and then I'll show you a super easy way to adjust the labels. Oh, it does not like it says I have multiple arguments for width. I don't think I do, but I need to take the width out. Okay, so 2 adjustments, I lied. Here we go. Okay, so you can see that the axis got kind of screwed up, right? So all I really have to do is change this X to a Y and change the Y down here to an X. And now I have fixed my labels. And it all looks good. So doing a more traditional bar that's vertical or horizontal, pretty easy. Doing a stacked bar is also pretty easy, whether you do it, horizontal or vertical. You basically are going to give it another series. And instead of just having one bar function call, you are now going to have two. But we just want to make sure that we are calling the same kind of bar function. Otherwise, it is going to be super confused. And because there is more than one series, you definitely want to include the labels. Now I think my labels are off again. Yep, this one needs to be X. And this one needs to be Y. And we can just say balance report or balance sheet, balance statement. And I do need to add the legend function in here. And I'm just going to do location and let it pick. So usually I do set the location to best, and then if I don't like where it is, then I move it somewhere else. But there is your stacked. And creating the horizontal stacked is not difficult. You will notice that it's just changing bar to bar H, getting rid of the widths, and then you have to make a little adjustment on your X and Y labels. In fact, what the heck, I'll go ahead and do that. So throwing in my H, going to get rid of the width. And we'll adjust my X and my Y label. Okay, so let's run this. And now we have a horizontal bar chart. So that's pretty straightforward. What's not as straightforward is if you want a clustered bar chart. And that ends up looking something like this. That is not quite as straightforward because you basically have to tell pyplot where the bars are going to be placed on that x-axis. And that's what makes it a little bit more difficult. And to do that, we are going to be using a function called arrange, which is in a different module. So we have to import numpy. And I look at it and I think it looks like numpy, which I think is funny. So in my head, I'm calling it numpy. So we're going to import numpy as NP. Okay, so that is necessary for us to calculate where these bars are going to be placed. Now, this numpy module is designed for arrays, and it makes array processing more efficient. Okay, that's kind of the purpose, but we're using it here to calculate the bar placement on our x-axis. So we did that import statement. You'll notice that we have to add bar width because that value is also required to calculate where we're going to be putting the bars. And then we get into the calculation itself. So for the first bar position, we are basically going to look at how long or how many items are in our revenue list. So we have 4 items in the list. So it's kind of using that as a base point. And then for the second one, it is adding in the bar width and taking into account what we've done for the first series of bars. Okay, and then for the third series of bars, it's taking into account what we've done for the second series of bars, right? It's adding in the width, it's looking at what we did for that second series. In this case, it would be the red bars. So it basically plots the green ones, okay, by, looking at how many there are. And then for the red ones, it is looking at our x-axis, it's looking at the width that we want our bars, and it's looking at what we did for the first series of bars. And for the third series, our gray series, it's looking back at the maroon bars and looking at what we did there. Okay, so I'm going to go ahead and copy this. It does not really matter what variable names you give this. The BR1, BR2, and BR3 made sense to me. If you wanted to just get rid of the R and say B1, B2, and B3, that works too. And then we do need to adjust the tick marks because now we have 3 bars and we want the ticks to be in the middle of those bars. And so that is what we are doing here with plt.x ticks. Okay, it's just trying to figure out, okay, now we've got more than 1 bar. What is the midpoint in each group? So once we add in those lines, okay, then we've got to take a look down here at the bars themselves. So now I'm not doing horizontal anymore. And I actually have 3 sets of data. So I'm going to add in my third one. Actually, I'll just copy all 3 because I changed this. And you will notice that instead of saying periods and revenues here, instead of doing periods, I'm inserting BR1 because I need to connect this series of bars with the calculation, and that is how I'm doing it. So I'm going to go ahead and copy this. Okay, so just take a look. Right now, the X series is periods. It would be periods for all the bars. And so here I have made a little adjustment. And I've got BR1, 2, and 3. Revenue, fixed expenses, variable expenses. Those are my Y series. And I've got my colors, labels. And there is one little adjustment we need to make. This length actually should be periods because we are using these to replace the periods in the bar. Before I had revenues in there, and that would have been incorrect. We are doing revenue on our y-axis. So this needs to be periods because that is what we're plotting along the x. Okay, and then once you have that, I think at this point we have everything we need because we've got our labels in there, the widths, we've got different colors for the bars, we've got our legend. I'm going to go ahead and run this. And let me pull this over. And there you go. So pie charts are usually used to show how different values contribute to the whole. To create pie charts, we use the plt.py function, and we send it the values that we want to chart. If we want wedges exploded, we actually have to create a list and enter 0 for each wedge that we don't want exploded, and then a value between 0 and 1, so decimal, for the wedge that we do want exploded. We have to send it a list of labels, and this is the text that would be associated with each wedge. We have to send it a format for the numbers. And then I think it looks nice if we turn the shadow on. So we will set that to true. And then if you want to kind of rotate the pie and have a different wedge at the top, you can adjust the start angle. So I'm going to go ahead and copy this. And this is actual data. And let me paste it in here. So here are my labels. And then I've got a list with values that are going to be charted. And what pyplot does is it automatically converts those into percentages. And then I have a list here for exploding a wedge. So this kind of corresponds to each number and the numbers that I do not want to explode. And when you explode, it actually separates the wedge from the rest of the pie. And for the numbers I don't want to explode, I put zeros. Okay, and so I'm only going to explode the first one. And so I put 0.10, but you can kind of experiment with the numbers and see how it affects how far the wedge is from the rest of the pie. And then I did create the variable that I'm calling AX1 for my axes using plt.subplots. And I am using that AX1 variable to call my pie function. I am passing it the values, which is the number of pets. I've got explode equals. I'm setting that equal to my explode tuple. I've got labels equal, and I am setting that equal to my label string here. Auto percent. So auto percent, I'm going to explain what that does when I run this. It's easier to explain it when you see it. Shadow equals true. We'll put a shadow on the bottom. And the start angle right now I have at 0. To ensure that the pie is a full circle, I am using axis and I am passing it equal. Okay, and then I'm adding a little title and I'm showing. So when I run it, I'm going to get something that looks like this. So where this auto percent comes in is I've got this thing formatted to display a decimal and a percent. So I've got 3 values. I've got 1 decimal. The 0.1 is for 1 decimal place. If you have a decimal place, you have to use an F for float. And then the format of this is a percent. Now, could I display this differently? Yeah, I could. If I change this to 0, let me close it, then I won't have any decimals. If I change this to a 2, and I get rid of the F, which stands for float, and I get rid of the percent sign, and I just do a D, which is for integer. Oops, and it does not like that. Yep, I think I'm going to have to put that back in. Oop. All right, it's liking it now. It definitely wants the percent. But I could do a 2D, which is integer, or if I want the dot and a decimal, then I have to use the F. It does make sense that is kind of forcing you to do percentage here because it automatically is calculating the percentage. So this number 142 is lost. So it doesn't matter how I try to format it here, I'm not going to get that number back. Okay, so it has already done the calculation for the percent. So the fact that it's forcing you to do a percentage in here makes total sense. Otherwise, your graph would be quite deceptive. Okay, but you can see what happens when I change it to 2 decimals. Okay, so whether you display 1 or 2, totally up to you. It comes down to personal preference. What about that start angle? So I am going to change the start angle. You can make it positive or negative. So I'm going to set it to 40 so you can see the direction it goes. And you would think it would go to the right, but it goes to the left. So if I want it to rotate to the right, I got to use a negative 40. And now it has rotated to the right. And I would probably want it to rotate a little bit more. Oops, 460 is going to be way too much. Yeah. Okay, so it's just kind of a matter of playing around with it until it looks the way you want it to look. Okay, and here are the different or the more useful formats, which I just kind of showed you up there. What if you want to change the wedge colors? Well, that is another argument you can pass. But you do have to set up a tuple like this. And let's pull this back up. And I will throw this below explode. And then you'll notice that there's a colors argument. So you'd set the colors equal to whatever you called your tuple. And then we run it. So a histogram. Histograms are kind of interesting. They are for larger sets of data, and you are going to probably want to sort the data because you have to figure out how many groupings or bins you want the data placed into. And so then your bars end up representing the groupings or the bins. And so this is a dice rolling program that I quick wrote up. And you can see I've got a dice list and I'm rolling the dice basically 500 times and adding to the list. And then I did 6 bins, one for each number, and labeled the axes. And then this is how it ended up looking. Here is another example. So for this example, I have weights that were calculated over 30 days. So I'm going to copy this one. Okay, and that should all be on one line. Now, in order to determine the bins, I think it is helpful to print this, whatever list you have, to run it through the sorted function and print it out. So you might want to comment out your other code and just take a look at that sorted data. And then kind of look for logical breaks in the data so that you can figure out how many bins to create. And that's my helpful hint of the day. So when I looked at this data, I thought 9 bins. Okay, and what you want in a histogram is for it to kind of look like this, right? You want all of the bars connected like that. So if we run it, okay, that's what it looks like. Now, if you have too many bins, then it's not really going to look much like a histogram. Okay, and if you have too few, it's going to look like a big old pink blob here. I guess that doesn't look too bad. If you don't have quite enough, sometimes it looks very blobby. So it does help to try to sort that list and figure out the number of bins. Now, Matplotlib comes with something called a color map. And so it's a gradient. It goes from one color to another. And it's used for patterns, okay? So it's used to emphasize a pattern. So it is really intended for scatter plots and that type of thing. You can apply it to like a bar plot, but it does not make sense. You're not going to get a nice gradient color in your bar. What it'll do is it'll just pick up color and all the bars will be that color. So it doesn't look quite as nice as it does on a scatter. Okay, because again, it's used to emphasize a pattern. So to use this, this is that test score example that we were looking at earlier. And let's see if I can pull this example up. Okay, so here's that test score example that we were looking at with our scatter plot. And what we have to do to apply a color map. is we have to create a subplot or a subplot variable. And then I got to use that variable in here. And then I no longer am going to be using color. And let's see. Now, for a color map to work, you have to connect it to your Y series. And my Y series, in this case, I'm actually using the score range for my Y series. So that's what I'm going to connect it to. But you have to connect it to a Y series or it's not going to work. So I'm telling it what Y series I am going to connect it to. Then I can tell it which color map I want. And I have to use the CMap argument. It's plt.cm dot and then the name of the color map I want to use. So I chose spring, but there's a bunch of them. You just have to spell them right. And I did list them up here and give you examples of what they look like. Okay, and I think everything else is pretty much the same. So I'm going to run this. Okay, and that is what Viridis looks like. And remember, you can adjust the size. So if I wanted to, in fact, I did in this example, because it's easier to see the dots. And let me change to a different one. Oh, we'll try accent. I haven't looked at that one yet. Hopefully I spelled it right. Oh, I think it has a capital A. Yep. Oh, it's so picky. There we go. Yeah, let me pull it over. That's what accent looks like. I actually like spring, at least for the patterns. I could see the patterns the best with spring. So you guys all have to decide what you like. And you are going to be creating your own. Let's see. The next set of videos is going to cover another feature that is part of Python. It's a module called Plotly.